Today, let's play Russian roulette. If this cute pink balloon represents you, what choice maximizes your survival chances? To boost your survival odds, let's review the classic rules of Russian roulette. Load one bullet into a 6-chamber revolver. You spin the chamber and close it, keeping the bullet's position a mystery. I've also inserted a toothpick into the soft bullet. It will have a lethal effect on the balloon. Then, you cock the gun, aim it at your head, and pull the trigger. With only one bullet in the chamber, you have a 5/6 chance of surviving and a 1/6 chance of dying. Okay, with one bullet, it's relatively easy to survive. Now, let's increase the difficulty. We place two bullets next to each other in the chamber. In this scenario, if your opponent has already fired once and missed, should you take the second shot directly or spin the chamber before firing again? Which choice do you believe boosts your survival odds? Most would argue that spinning the chamber naturally improves your chances. Because the opponent has already fired a blank, using up one chance to survive, continuing to fire seems riskier. Is that really the case? Let's take a closer look. Since the gun rotates counterclockwise with each pull, if the first shot was a blank, it must have hit one of the 4 empty chambers. If the first shot lands here, you're in trouble when it's your turn. But if it hits any of the other 3 positions, your shot will also be a blank. So, if the first person fires a blank and the second person doesn't spin the chamber and fires directly, the survival chance is 3 out of 4 or 75%. After spinning the chamber, the probabilities reset, leaving 4 out of 6 chambers empty, resulting in a 4 to 6 survival chance, which is 67%. Notice that firing without spinning the chamber offers an 8% better survival rate than spinning it. Surprised? But what if the 2 bullets are placed randomly? They might be adjacent or separated by 1 or 2 empty chambers. In this case, is the survival chance still higher if you don't spin the chamber? As we mentioned earlier, when the bullets are placed adjacently, the probability of surviving without spinning the chamber is 3/4. When the bullets are spaced by 1 chamber, if the first shot lands in one of the 4 empty chambers, the second shot won't fire a bullet. If it hits this spot, the second shot also won't fire a bullet. The other 2 positions will fire bullets. Thus, without spinning, the second shot has a 50% survival chance. If the bullets are 2 chambers apart, the second shot won't fire a bullet if the first shot hits this position. If it hits here, the second shot won't fire a bullet either. The other 2 positions will. So, the survival chance remains 2 out of 4. Randomly placing 2 bullets has 6 possible adjacent positions. There are also 6 possible positions with 1 chamber in between. There are 3 possible positions with 2 chambers in between. In total, there are 15 possible scenarios. So, the probability of randomly placing 2 bullets adjacently is 6 out of 15. The probability of surviving the second shot when the bullets are adjacent is 6 out of 15 multiplied by 3 out of 15. Similarly, the probability of randomly placing 2 bullets with 1 chamber in between is 6 out of 15. In this case, the survival chance is 6 out of 15 times 2 out of 4. The chance of placing 2 bullets with 2 chambers in between is 3 out of 15. In this case, the survival chance is 3 out of 15 times 2 out of 4. Summing these up, the probability of surviving the second shot without spinning the chamber when 2 bullets are randomly placed is 3 out of 5 or 60%. The survival chance with spinning the chamber stays at 2 out of 3 or 67%. Now we know that placing 2 bullets adjacently increases your survival chance by 8%, while random placement decreases it by 7%. Although this conclusion isn't magical enough to guarantee 100% survival in Russian roulette, is an 8% increase in survival chance insignificant? Humans and chimpanzees have only a 1.3% difference in DNA. Biden's vote percentage was only 4.5% higher than Trump's. Enhancing global road safety by 8% could save 104,000 lives each year. If you were in a life or death scenario like this balloon, in a life or death situation, would you really disregard an 8% increase in your survival chance?